Hey, year 13s. I'm just dropping the link for this video, copy into our Hangout chat, just so you can find it. Paste, go. There we go. And it looks like sleeping a minute. There you go. And I should be live straight away. Just so I'll swing that. Paste. There we go. Oh, stop. Made a mess. Made a mess. There we go. Stop. And then I'll pop out the chat. Hey, Julian. Thanks for coming. Pop out the chat. Right. Okay. So today's lesson, we're doing reactions of benzene. Our learning objectives are know the mechanism. Know mechanism for BZ. Benzene. See what I did there? And then understand. Oh, was it an understand? Oh no. Where are my learning objectives? Oh no. I actually. Have I just done something wrong? No. There's my stream. Edit. That's on my learning objectives. Okay. So it's just no acylation. Okay. Fine. So no, then understand acylation. By the way, Friedel-Crafts, technically. I'm just going to pop out that. So this has actually got a rather awkward name. You can add this on. This is called Friedel-Crafts acylation. Also acylation. You've got Friedel-Crafts alkylation, but you don't read alkylation. Alkylation. Then you've got halogenation, and nitration. So these are what we need to do with benzene. Okay, so first thing we need to do is so benzene. We know benzene, BZ, is much more stable than other alkenes due to a delocalized electron system. So, could you share your screen? Thank you. Share. Yes, of course. There we go. Thank you, Tenzi. Thank you. We know BZ is much more stable than other alkenes due to a delocalized electron system. Okay. Normal alkenes go through electrophilic addition. Let's remind ourselves of what that looks like. Alkene. Let's now add, let's just stick with ethene, make it easy for ourselves. Let's add HBr. HBr is polar due to differences in electronegativity. The double bond reaches out, the single bond breaks. You get an intermediate, the double bond is broken. The H, I'm going to put the H here and the positive there. And then the Br is now going to hop on to that. Two-step process, electrophilic addition. Benzene doesn't do this. The reason being is benzene does not want to break its delocalized electron system. It always wants to keep it. Therefore, the mechanism is different. And by the way, this mechanism is only done by benzene. So benzene So I often write down benzees. Yeah. The reason why I do this is I know that it's benzene. I'm not going to do that in my exam. I know that this isn't going to be the case. But it reminds me that that benzene goes through ES Translate electrophilic substitution. It does not do addition reactions. It doesn't want to. It wants to keep its delocalized electron system. So what it will do is a substitution instead. Let's have a look at what that looks like. So here's what the mechanism looks like. You've got benzene, and benzene has a huge number of electrons. This is an electron-rich center. Electron-rich, don't like rich, dense. Electron-dense center. However, the electrons are all linked together in the pi system. What that means is it doesn't want to reach out. Yeah, if you show this to bromine water, now bromine water will become polarized. It's non-polar, but will be polarized on collision. Benzene will not, that's actually a terrible line, I've made a mistake. Benzene will not reach out. No, it won't do it. The reason being is the electrons are locked in a delocalized system. In order to be able to pull those electrons out of that system, you need a much better electrophile. None of this partial charges rubbish. Yeah, what we want to do, what we need to do is we need to rip it out with something way more powerful. So what can we do with benzene? So I'm now going to do all three of these things simultaneously. So BZ reactions. BZ, I've started now. Benzene reactions. So first thing I can do is I can take benzene and I can add, by the way, I'm also going to draw this out properly to show you this because it's really important. I need to explain to you the substitution. What's being subbed? What is being subbed is the hydrogens. Yeah, we know that benzene has got 6 hydrogens and each one of those is on a carbon. Yeah, we now have this delocalized system in the center. Yeah, and what's now going to happen is I'm going to be able to swap these H's for people. So what can I swap them for? So I can do this. I can add, the first thing I can add, I think it's reasonable to start off simple, is I can add a Cl. The second thing I can do, this is called halogenation, or chlorination if you prefer. Yeah. The next thing I can do is I can swap a hydrogen for a nitro group. Yeah. This is nitration. The next thing I can do is I can add an alkyl branch. I could add CH3 if I wanted, or alternatively CH2, CH3, or CH2, CH2, I could add a propyl branch, a methyl branch, an ethyl, I can add any branch I like, but this is alkylation. This is alkylation, adding an alkyl branch. And then the last thing that we can do is we can add an acyl chloride group. So we can add, it's not actually an acyl chloride. Sorry, I apologize. This is acylation. Acylation. But the group that's being added is an aldehyde. Really, an aldehyde or a ketone in this case, depending on what you're adding. So you're adding the C double bond O. These are the 4 options I've got. Right. So what we're now going to do is we're going to look at each reaction independently and look at what's happening. So first things first. So number 1, let's do chlorination first. Chlorination, or halogenation, bromide, iodide, if you want, iodine, if you wanted that, bromine, whichever one. But this is chlorination. I want the bromine to react with chlorine gas. Now, it won't react with chlorine gas as a pair. No, that reaction will not happen. So what we need to do is we need to do another reaction first. We need to rip that chlorine in half. So what we're going to do is we're going to add a catalyst. Add a catalyst. Now that catalyst is aluminium chloride. Now, aluminium chloride loves chlorine. Aluminium chloride is going to react with chlorine gas, and it's going to rip off a chlorine with its electron and leave me with Cl+. Now, this is the catalyst reaction. And now we have a powerful electrophile. Right, electrophile. It's fully charged. Now we can do the reaction. That one doesn't happen, but this one does. Here's the mechanism for benzene. Right, so I've now got Cl+ fully charged. Right. So the double bond, which is in the circle, the electron dense region, is going to hop to the chlorine. Now I need to make something clear here, guys. This looks really easy, but there are these tiny little details which teachers often forget to teach. Notice number one, my arrow is curly. Yeah, it is curving over a corner. It's telling me where the chlorine is going to go. The chlorine is going to be going here. Yeah. Now, if I had done this curly arrow, if I had done this one, that there is, I've just lost my mark. I've gone through a corner, and that is not allowed. Yeah? The next thing is it can't be straight either. If it's straight, you lose it. What we need to do is we need to start, we look at where we want it. If somebody said, let's have, so I'm going to position A, position B, and position C. I'm going to ask, Winkit, what position would you like me to put the chlorine ion, please? Where do you want me to attach it to? A, B, or C? I know that there's going to be a delay. Oh, Donna. Yeah. Oh, no, it's all right. You're having a nap. I'm just going to get myself a drink of water. I've got to wait first. It's fine. It's good. Okay. Are you okay? Cool. So Winkit wants me to add it on at position C. He happens to have picked the most awkward one. I feel like you did that on purpose, Winkit. Thanks for that. If I'm going to add it to C, number one is I'd want to put the Cl somewhere else. Yeah, I'd probably put the Cl here in my diagram. And I'm going to do this. I'm going to start here or here. I've got two choices here. Yeah, I don't have to start, because I want it to go up this position. I can start at either point, but I need to show the curl. Yeah, and I'm going to do that. That now tells me that I am putting that onto position C because I'm curling over it. I could have alternatively done this. That would have been okay as well. It's still not quite in the middle. I probably would have more like done that. That would have been okay. Yeah, either one is fine, but I'm curling over the corner of the structure I'm trying to put it on. Right, so what does this now look like? I now have an intermediate. I now have this. So the chlorine is now attached to position C, but the hydrogen is still attached too. Now what this means is, it tells me that the ring is going to be broken. And it's being broken in a very specific place. Do you notice what I've done? The corner that Winkit chose, I have to take the corner of each of these and then draw a horseshoe that join that is between them. That shows that the ring is broken towards the chlorine. Next, we're not quite finished. One more step. What now happens is this. That hops back in, and the H breaks off. So the final product is exactly what Winkit wanted. He wanted the Cl at position C. The hydrogen is gone, so that the byproduct is H+. However, the catalyst is a catalyst, which means it's regenerated. So the regeneration of the catalyst is that the H+ that's produced will react with the HCl4 minus, turning back into AlCl3 and hydrogen chloride. And we're done. Regeneration of the catalyst. Regeneration of catalyst. So if we had done this with a bromide, you would have used AlBr3 instead. I think actually you can actually use AlCl3, I think, in reality. I think it still works. I think it actually works better in reality. Guys, can you hear me? Can you hear me okay, guys? How's that? Is it back? Go, go, go. Is it there? We won't continue if it's not. Yes, amazing. So we want to go from benzene to nitrobenzene. NO2. Right. So what we're going to do is we're going to take, so the first thing is benzene won't just react with NO2 as a gas. It wouldn't do that. Yeah, what's going to happen is we need an electrophile. And once again, this is going through electrosub. So here's what happens. I'm going to take concentrated nitric acid. I'm going to react it with concentrated sulfuric acid. Now, these two are going to react together in an acid-base reaction. You guys haven't done acid-base yet, so you won't know this. But the sulfuric acid is diprotic. It is stronger. It's going to pass the proton over to the nitric acid. And it's going to form this. It's going to form that. Right, this goes through a second reaction. By the way, this is acting as the base, and this is acting as the acid, if you're interested. Yeah, that's what's happening there. Now a second reaction happens. The H2NO3 goes through thermal decomposition to form H2O and NO2 plus. And there is my powerful electrophile. So you've got to know all these equations, guys. These two equations, by the way, can be combined. Oh, no, Mr. Duncan, could you explain the chlorination after the horseshoe bit due to my, yes. So, yeah, so after the horseshoe, and we get, what happens is the byproduct is the H+. That this hydrogen breaks off without its electrons and forms H+. That H+ will immediately react with the product of the original catalyst reaction, and it will regenerate the catalyst, which was AlCl3. Yeah, so it's just the really, and then the role of the chlorine was the chlorine positive ion, was the electrophile, and it's a substitution because the hydrogen is being swapped for a chlorine. I also mentioned that if you wanted to put on a bromine, you could use AlBr3, but I think you could probably use AlCl3 as well, and I think that would probably be better, but they've never asked a question on it before, but I think they'd allow it. You'd just swap everything for Brs and run the same process. Right, now we've got our nitro ion. By the way, this is actually called, this here, nota bene. This here is called the nitronium. Nitronium ion. Got to say it with an evil voice. This is the nitronium ion. Yeah. So now that I've got the nitronium ion, I can now run my mechanism. Benzene. Hello, benzene. Right. Let's zoom in. Let's go A, B, or C? I'm going to ask Julian, where would you like me to put it? Gonna buy myself a really expensive splitter. Powered one as well. A. All right. So he's chosen A, so I'm going to swing. That's actually a really good choice because you now have to do that. It's done a really good choice there, guys. You're right. Now, this is really important. You must, whenever you're doing electrophilic sub, any A2 mechanism, the charge that the molecule has must go on the correct atom. And it's the N that owns this charge. So if I want to go to the A, I'm going to start about there, and I'm going to reach over A. Right, product. Here's what I've formed. And I've added the NO2 to here, and the H now appears out of nowhere. I need to look at these two corners and draw a horseshoe and add a plus. There we go. I don't actually like the circle when we do that. There we go. One more step. We're nearly done. Ah, too fat. Let's try that again. There we go. Done. It's all over. 2 curly arrows. How easy is that? Really is simple when you can do it. Right. Product. Gotta love benzene. Product. Nitrobenzene. There we go. Nitration. This becomes nitrobenzene. The nitro group is the lowest ranking group of anybody. Cool. So nitration, done. The hard bit really is you've got to learn these two. Learn those two. The equations to produce the electrophile. Yeah, that's what they'll ask you for. Right. On to the next one. Let's go for the next one. Right, the next one we're going to do is we want to have this. The next one is alkyl. Oh, sorry. Regeneration of the catalyst. Sorry. Regeneration of the catalyst. The H plus ion will now react with HSO4 minus to turn back into H2SO4. Amazing. There's the regeneration of the cat. Regeneration of catalyst. Next, alkylation. Friedel-Crafts, alkylation. So now we want to take benzene and we want to add, oh, messed that up. I want to add an alkyl branch like ethyl. Yeah, I'm going to say benzene, and I want to add I'm really not drawing it very well. Let's add a methyl, or I could add an ethyl. Could do that. I could do a CH2, CH3 if I'd like. Yeah, I can do anything I like. So how do I do it? What I'm going to do is I'm going to have to go and get a halo alkane. Because what I need, let's keep it simple. Let's keep it easy to begin with. Chloromethane. Right, and what I need to do is I need to rip the chlorine off. Does anyone want to have a guess at what the catalyst is? Add AlCl3. AlCl3 will rip the chlorine off, and it will leave me with an alkonium ion. This here is, I'll highlight it. This is called the alkonium ion. Right, now we can attach it to benzene. Now we've got our powerful electrophile. Now we can run ES. Right, benzene. Making them all different sizes, solvable. So I'm going to do CH3 plus on the C, circled. Right, I want to put it here. So my curly arrow must reach over it. There we go. I'll do nicely. Right, product intermediate. So I've now attached it to here, and a H has appeared out of nowhere. Draw your horseshoe and add your charge. There we go. Next, one more curly arrow, and I'm done. Regeneration of the catalyst. Let's draw the product. There we go. Regeneration of the catalyst. H plus reacts with AlCl4 minus to produce AlCl3 and HCl. Regeneration of the catalyst. Nice. So we've just done halogenation, nitration, and now alkylation as well. We're doing really well. 2 more minutes. Last one. Acylation. 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 So for acylation, the name acylation, Friedel-Crafts acylation if you want. Friedel-Crafts. Friedel, I can't spell Friedel. I don't know if the I's there or not. Friedel-Crafts acylation. The reason why it's called acylation is because you're using an acyl chloride. So I want to take benzene and I want to add a group with a double bond O in it, like this. Yeah? I'm going to ask people on the chat, please, how do you name it? Can you name that for me, please? So we want to turn, I've suddenly realized I've done that wrong because I want to go from benzene to that. Really not doing a good job of this. I want to add this group to it. Friedel-Crafts acylation. Name this, please. Hard one, not easy. Right, I'm going to take an acyl chloride. Guess what the catalyst is? The catalyst is because I want to add this section. Guess what I need to remove? Surprise, surprise. Chlorine. So I'm going to take AlCl3 again. And I'm going to rip it off. AlCl4 minus and C, double bond O, fully positive. And yes, this is a very acylium ion. Acylium ion. It's a very Cillian ion, very Cillium. I'll stop. I'm going to stop. So, right, now I've got my electrophile. Electrophile. Fully positive. Right. Benzene. Right, draw it out. C double bond O on CH3. Realize I'm orientating it as I need it. There's the full plus. Right, I'm going to put it here. Product. You'd have thought my pictures of benzene would get better. That does not seem to be happening. So I've now attached this guy, and a H has magically appeared, and I've got to break my ring, horseshoe, and it hops back in, and we're done. All over. Regeneration of the catalyst, surprise, surprise, is the same. It's been a lot. That was hard, that. I've actually got a sore back off that. That's ridiculous. Hang on, not quite. Right, guys, that brings me to the end of my lesson, folks. I know that was a pretty hardcore lesson, to be fair, but there is a reason why I don't tend to split them up. The reason being is there's similarities in all of them. The mechanism is a doddle. You've just got to remember those little key tricks about hopping over the corners and, you know, breaking the ring correctly. But the mechanism is actually a very easy two-step mechanism for A2. The tricky bit is remembering all those bloody generation of the electrophile equations. And I do them all in one go because you realize that 3 out of the 4 are the same. You just need aluminium trichloride, and it'll just take the chlorine off. I'll show you some questions of this next lesson. In fact, I'll post it homework for you guys to have a look at. We've had 4 lessons on benzene now, and we've rattled through it. We're kind of not exactly far off benzene. I need to do activation, deactivation, and then directed sub. And I think we're done for benzene at that point. I think so. Yeah, and then I'm going to go to aldehydes and keto. So I've already got 2 more lessons. Yeah, guys, only 2 more lessons on benzene and we're done. And then you've got a test on it. So just bear that in mind. I know that you've got a maths exam, all of you do, and I don't want to distract from that. So, you know, don't worry about it quite so much. But anyway, I'll leave you guys be. Have a nice rest of your day, and I'll see you soon.